Hi, today we're going to look at 0 as an exponent. We're going to look for a rule that would define what it would mean. Rather than just hand it to you, I think we'd like to maybe see if we could figure it out together. And we'd use two ideas that we've already encountered. The first, any quantity divided by itself equals 1. So that means 8 over 8 is 1. That means x over x is 1. That means 20 over 20 is 1. That means 5n over 5n equals 1. All of these are expressions that are equivalent to 1 because it's a quantity over itself. The next idea that we'll want to recall is that when we have x to the 5th over x squared, because the bases are both alike, they're both x's, we're allowed to subtract the exponent. So that becomes x to the 5 minus 2. We learned this in a previous video. So it's legal to subtract the exponents so long as these bases right here are alike. Let's take these two ideas and apply them to 0 as an exponent. Let's pick a random variable, b to the 8th, over b to the 8th, and you agree that this is a case of a quantity over itself, so that should be equal to 1. Anytime we take a quantity and divide it by itself, it should give us 1. If we look at b to the 8th over b to the 8th a second time, and recall that we're allowed to subtract the exponents because the bases are alike, this should be equal to b to the 8 minus 8 power, which is equal to b to the 0. Basically, if all of this equals 1, and it is also equal to b to the 0, it means that b to the 0 and 1 must be two ways of writing the same thing. So we have our rule, b to the 0 is equal to 1. And b, of course, is a variable, so it can take on lots of values. And this means that 3 to the 0 is equal to 1, 8 to the 0 is equal to 1, 10 to the 0 is equal to 1, x to the 0 is equal to 1, and in fact 3x squared y to the 4th, all raised to the 0 power, is also equal to 1. One thing you have to be careful about is if somebody gives you a problem like this, while it is true that x to the 0 would be equal to 1, we still have to pay attention to the order of operations. Since we would normally do powers before multiplication, this is not a case of 3x to the 0. This is 3 times x to the 0. So what that would give me is 3 times 1, and that is equal to 3. So this rule does not somehow suspend the order of operations. So what you should take away from this video is that a quantity to the 0 power is equal to 1. That was the rule we were seeking to develop. I hope you found this video helpful.